Hi grade 11s, we're on to topic 3 of analytical geometry, which is that of straight lines. Now, you probably will find all of these examples are things that you should vaguely know how to do. Reason being, straight lines are part of functions, which we've done, and so this is quite a good revision of that. And some of these concepts are things we've covered in gradient. So you might want to hit pause every now and again, try the question by yourself, and then watch the video to confirm that you're right. So let's just go over a couple of examples. So example 1 says, determine the equations of the following lines. So line passing through the point, so they give us a point on the line, which is always good. Oh, and a gradient of -2. So why I chose this question is just to remind ourselves that the equation of any straight line is y equals mx plus c. We should know this from functions. We should know that m stands for gradient, and we've discussed gradient at length in the previous lesson. And then c stands for our y-intercept. Straight lines form quite a big part of analytical geometry, and that's why we're doing this topic on them, because you'll notice in the past paper questions the equation of a straight line comes up a lot. So in this particular question, they've told me the gradient, so it's -2x plus c, and then we should know from functions that as long as you have a point on the graph, that's wonderful, because you can sub it in. So that means y is -4 when x is 3. So you substitute it in and solve for c. So I get -4 equals -6 plus c, add 6 to both sides, and I get c is 2. Now don't forget to answer the question, because it said find the equation of the line. So the answer to my question is -2x plus 2. So I'm just going to write a note to myself over here, sub in point to solve for c. Don't forget that if you ever have one unknown in any equation, any function, you just sub in a point. In this case, to solve for c. Great, let's move on to the next one. Next one says, determine the equation of the straight line was the question, of the line passing through, and now you've been given 2 points. So don't forget my equation, which is y equals mx plus c. In this case, I wasn't given my gradient. However, I almost was given my gradient, because on our formula sheet, something we've discussed is the gradient formula. And as long as you know 2 points on the graph, as we discussed in our previous video, you can find the gradient. So in this case, now remember, it doesn't matter who's point number 2 and who's point number 1. So let's make this point number 2, and let's make this point number 1. So change in y is 2 minus 2. Now the moment I do that, I'm like, hang on one moment. Let me just complete the x's. So -4 minus -1. What does this mean? This means there's no change in y. So the moment I saw that, let me just think about what this looks like. Where is -1, 2? -1, 2 would be at about there. So -1, 2. Where is -4, 2? -4, 2 would be somewhere down there. This would be -4, 2. So what is this line they're talking about? It's a horizontal line. So immediately I can see, hang on, my gradient's 2 minus 2 is 0. This gradient is 0. So this graph is y is equal to 0x plus c. And so immediately I don't really have to go forward. I could go forward because I could sub in. If you still hadn't picked this up, you could sub in a point. So you could say, great, y is 2 when x is -4, but 0 times -4 is just 0. And so c is 2. So from this, I know y is equal to 0x, which is just 0, plus 2. Now, I should have picked that up the moment I substituted in that 2 minus 2 in the numerator of my gradient. I was kind of like, hang on, there's something weird here because there's no gradient. So this turns out to be a horizontal line, which means I know that every horizontal line has the equation y is equal to something. And in this case, I can see the y value is always 2. So, a bit of an interesting one there. Right, next one. What about the line parallel to 3y minus 2x equals 6 and going through 9, -1? Well, first of all, parallel lines, something we've discussed before, means they have the same gradient. However, something we've also discussed before, you cannot tell the gradient of a line until it is in standard form. So this is not in standard form. So the first thing I would do is I would bring over my 2x. Then I would divide by 3. Remember that everything gets divided by 3, so 6 gets divided by 3. And I don't really care about the 6. Actually, all I care about is this gradient, because my line is parallel to that line. So therefore, the gradient of my parallel line is also 2/3. So therefore, I know that the graph I'm looking for will also be 2 over 3x plus c. So this is just revising parallel lines. They did give me a point, so y is -1 when x is 9. I would use my calculator. Oh, sorry, let me scroll back up. I would use my calculator. So 2/3 of 9 is 6 plus c, and I get c is -7. Again, don't forget to actually answer the question. So what is the equation of this graph? It's 2/3 x minus 7. Right, let's have a look at another one, just as a revision almost, because perpendicular lines are something we've discussed before. Remember, perpendicular lines, the gradients multiply together to give you -1. So this gradient of line number 1 is equal to 1/2, so we can use the cheat or the shortcut. And the shortcut is swap it round, so it's now 2 over 1, which is 2, and change the sign. So how did I do that? I swapped the fraction around, and I changed the sign. Why? Well, because they have to multiply together to give -1. And so I need everything to cancel, so that's why I flipped it over, and I need the negative sign to multiply together to give me -1. So I because I didn't have to prove they were perpendicular, I used the cheat or the shortcut method. So now I know my graph is y equals -2x plus c. Again, they've given me a point, so they've made my life fairly easy. So 2 is equal to -2 times -6 plus c. So 2 is equal to 12 plus c, and -10 is equal to c. So when I answer the question, I know y is equal to -2x minus 10. So far we've pretty much done a little bit of functions with, how to find the equation of a straight line, what m means, what c is. We've done parallel, we've done perpendicular, and our last one is something which we haven't really discussed probably since grade 10, and it's something that's really important. And this is the idea of a perpendicular bisector. So this one's I'm going to go through a little bit more slowly, and I'm going to draw a point so you can visually see what that means. So let me draw the graph of these points. So A is the point 3,5. Now, don't forget, when we're sketching, we never actually draw accurately. Now, I'm going to move this down a bit because those points were so high. So 3,5, let's pretend it's there. Remember, we're not drawing accurately. 7,17, well, that'll be higher and quite high there. So 7,17. So there's a line segment. Now, a line segment just means it's a line that starts and stops. It doesn't carry on forever. Now that's actually quite important in this question, because the first word says perpendicular, which means I know that it has to be at 90 degrees, and the second word here says bisector, and bisector means cut in half. Now if this was a straight line that goes through these 2 points and carries on forever, then there is no middle, because there is no middle of something which carries on forever. So that's why they had to say line segment, because it starts at 3,5 and it ends at 7,17. You have to have a finite line in order to be able to cut it in half. So basically they want, when they say perpendicular bisector, it is a line that is at 90 degrees to this segment, and it cuts the segment in half. So if I summarize what this means, a perpendicular bisector is a line that is at 90 degrees to AB, because this was actually called A and this was actually called B. So this line must be at 90 degrees to AB, and it must cut AB in half. Now that's great, because if it cuts it in half, that means it goes to the midpoint of AB. So the question is, can I find the midpoint of AB? Well, absolutely, because I have a formula to do that for me. So what's the midpoint of AB? Well, add the x's together and divide by 2. Add the y's together and divide by 2. And so that'll be 10 divided by 2 is 5, and 22 divided by 2 is 11. So I know I've got the point 5, 11, which is on this line segment. Now, perpendicular bisector means that this straight line, although that doesn't look very straight, forgive me, is at 90 degrees, and this is what we call the perpendicular or perp bisector. So that's what they want. They want the equation of that line. Now, I don't have much so far because all I've got is a point on the line. Now, that's a start, but I've got to have 2 points on the line if I want to be able to find gradients, and I don't know any other point on the line. But these two lines are perpendicular. And what do I know connects perpendicular lines? The thing that connects perpendicular lines is the gradients. So can I find the gradients of AB? Because if I can, I'll be able to figure out the gradient of this perpendicular guy. So what's the gradient of AB? Well, gradient is change in y, so 17 minus 5 over change in x, 7 minus 3. Now I'm expecting a positive gradient because otherwise I made a mistake because my picture looks like it's going up. So 17 minus 5 is 12. 12 over 4 is 3. So therefore, what's the gradient of my perpendicular line? Flip it around, so it'll be 1/3, and change the sign, which again makes sense because this is definitely a decreasing gradient line. So in order to continue, I now know that the perpendicular bisector, the perpendicular part, has given me the gradient. So perpendicular part gives me the gradient, and now I need C. Well, that's going to be easy because I'm just going to sub in my point, which is my midpoint. So that means y is 11 when x is 5. Now don't worry at all if you get, improper fractions, because the moment you're dealing with perpendicular lines, you automatically start ending up with fractions. So it doesn't matter at all. So I'm basically going to say that if I multiply this very quickly, this is negative 5 over 3. And I would just take my calculator and I'd add 5 over 3 to 11. And we generally leave stuff as an improper fraction. We don't really care about making it a mixed number. So therefore, my answer to my question is the perpendicular bisector is negative 1/3 x plus 38 over 3. Now this is probably the only new kind of revision we've done in this video so far. So I'm just going to scroll back up again because it's really important, very commonly asked question. So first of all, just remember that a perpendicular bisector is the line that cuts the segment at 90 degrees and cuts it in half. So the perpendicular bit helps me get the gradient because I can work out the gradient of AB, so I can use the trick or the cheat or the shortcut to get the gradient of the perpendicular line. And then all I need to from there is find a point on the line, and I know I cut it in half, so it goes to the midpoint. We definitely will see that again before the end of this section, so we will revise it. Okay, example 2 is actually a really nice question. So example 2 says determine the point of intersection. So we're kind of revising functions here, and this does come up in analytical geometry a lot. So it says determine the point of intersection of y equals 2x plus 1. Okay, so that's one of the lines. There we go. And the other line is perpendicular to this line and passing through the point 0 minus 5. So I don't actually know the equation of the second line. So this second line I need to go and work out. So this second line is y is equal to mx plus c. Now what do I know about this line? It is perpendicular to y is equal to negative 1/3 x. So immediately I know this equation is negative 1/3, which means I know that this equation, the perpendicular line, is swap it around, so it becomes 3 over 1, which I can write as 3, and change the sign. So that's now positive. So therefore, my second equation so far is 3x plus c. Now, in order to find c, my y-intercept, I'm going to sub in a point. Now, here's my point, and what do you know? That happens to be the y-intercept. So if you're thinking on your feet at this stage, you will see that point and go, oh gosh, c is negative 5, that's the y-intercept. If you weren't kind of thinking too much because you're rushing, it would make entire sense to substitute it, and then you would probably go, oh gosh, 3 times 0 is 0, so negative 5 is c. That was a bit of a waste of my time. Doesn't really matter, because either way we land up with the fact that the second equation is 3x minus 5. So that is equation number 2. and they gave me the first equation. So this is the point of intersection of a straight line. Well, and a straight line, two straight lines. So I know that y is the same as this y. So I know that therefore 2x plus 1, which is the first y, is going to equal 3x minus 5. So basically what I'm saying here is that it's y number 1 is going to be equal to y number 2. That's what we're arguing, because remember, a point of intersection is a point where they hit each other, so they have the same x and y value at that point. And now it just becomes an equation to solve. So if I bring my 3x over, I get, let me write that better, 2x, take away 3x, equals negative 5 minus 1. So I get negative x equals negative 6, and x equals 6. Now, which equation do I work with to find y? It really doesn't matter, so I'm going to use the first one. So y equals 2 times 6 plus 1, so y equals 13. So therefore, the point of intersection is when x is 6 and y is 13. Now, if you want to check, what I always do in a test exam is I just check, if I put 6 in there, do I still get 13? Because if I don't, this can't be a point of intersection. But 3 times 6, so 3 times 6 would be 18, and 18 minus 5, guess what, is 13. So it's just quite nice to check that, because then you know if you've made a mistake and you need to go back and check something, or you know if you can, move on. Great, so hopefully a little bit of new concepts there, points of intersection, perpendicular bisector, but hopefully you're feeling quite confident with the straight line part of this, because it's something we've done so much. Now that's the end of topic 3, and so that's the end of our grade 10 revision. Grade 10 was all about gradients, distances, and midpoints in straight lines. So now after this topic we can start the really fun stuff. Okay, well done everyone.